Here I am logged into my Raspberry Pi Zero. After installing the operating system, you might ask yourself, now what? I can list my home directory, but that really isn't very exciting. As a general purpose computer, the Raspberry Pi Zero can be used for a number of things. It can be used as a Wi-Fi router. You can turn it into a basic smart home controller. If you like, you can turn it into a lightweight media server. You can even use it as a retro game emulator. At Clear Creek Scientific, however, we use Raspberry Pi Zeros to collect digital data. For example, let's suppose that you want to monitor the temperature of the internal processors in the Raspberry Pi. To get the temperature of the CPU, or the central processing unit, you can enter the command cat sys class thermal zone 0/temp, and then divide the printed result by 1000. So in this case it would be 39.008 degrees centigrade. To get the temperature of the GPU, or graphics processing unit, you can enter the command vcgen cmd measure temp, and it will print out the temperature for you, 39.0 degrees centigrade. Now you could run these commands at intervals and record the results manually, but wouldn't it be better to have a program that automatically collects the values and writes them to a file? That is why we have written a data logger program named CCS Data Logger that starts whenever the Raspberry Pi Zero boots. Here you can see it running as a systemd service. Today's video is about using the data logger and its companion program, the data server, to do your own data collection. The data logger stores collected values in a CSV, or comma separated values file, on the Raspberry Pi. You can see the output here. So far we've collected 4 samples. This video focuses on collecting the temperature of the internal processors running on the Pi. But the data logger is also able to collect data from external sensors connected to the Pi. In fact, our next video will demonstrate how to use the data logger program in a simple weather station to collect air temperature, humidity, and air pressure. Since the data logger is released under an open source license, you are also able to write your own data collection modules for sensors that we don't support yet. As I mentioned, we also provide a second systemd service that runs as a web server on the Pi Zero to display the data that is collected. We call it CCS Data Server. And here it is. To access the data on the server, I'll need the IP address of the Raspberry Pi. So let's find out what that is. The one I want is the IPv4 address under WLAN 0, which is 192.168.200.74. Now let me shrink the Raspberry Pi screen on the video so that you can see the web browser running on my laptop. The data server can be accessed through Wi-Fi from any device on the local network with a web browser. If I enter the IP address of the Pi Zero and the port number of the service, I see the home page of the data server that's running on the Pi from my laptop. On the home page, you find the most recently collected data values. We have a timestamp, the CPU temperature, the GPU temperature, and a Pi throttled status, which indicates whether or not the Pi has overheated or experienced a low input voltage in the past, among other things. The history page shows all the data values collected so far. The CSV page lets you download the data to another computer for post-processing, or delete the collected values from the Raspberry Pi. The ability to download or delete collected data is protected by a password that you set when configuring the data server. After you enter the password for the first time, the data server stores a cookie in the browser, so you won't need to enter it again until the cookie is deleted. So far we've collected one file here. We can either select it and then download it or delete it. If you are new to Raspberry Pi and Linux, you may feel a little uneasy about configuring and installing our logger and server software. Never fear. To make configuration and installation of the data logger and data server easier, we've created a quirky little program named Gambezi. It's a command line program that runs under Python on Windows, Mac, and Linux. We make it available for free on GitHub. You can find a link in the description below. Let me navigate to that page. To download the program, click the green code button and save the zip file to your hard drive. When it is finished downloading, extract the contents of the zip file. You'll need to have the Python programming language installed on your desktop to run Gambezi. Python can be installed through your operating system's package manager or app store, or from the Python webpage at www.python.org. Now I'm going to open a command line terminal window on my laptop. To use Gambezi, open your own command prompt and navigate to the directory where the Gambezi script was copied. To start, enter the command python gambezi.py. First, some Gambezi basics. At any of the menu prompts, you may enter the word help to see available commands. For help with a specific command, enter the word help followed by the name of the command. In this case, to see which applications are available for configuration, you can type show. You can see that the logger and the server are currently available. Start by configuring the data server. Enter the command configure server. The first time you try to configure an application, Gambezi downloads the necessary files for that application from our GitHub pages. Notice that the prompt changed from build installer to server. Running the command help shows a new set of commands specific to configuring the server application. Let's see what show tells us now. There are a couple of objects to be configured, paths and internal. We can type show paths to see the variables in the paths object. They contain the names of various directories on the Raspberry Pi where files will be stored. The names in parentheses are the currently configured values, in this case the default values. I suggest leaving the default values for the paths. If you do decide to change them for some reason, make sure that the CSV path you enter for the server is exactly the same CSV path you configure in the logger. Otherwise, the server won't be able to find your data files. If you type show internal, you see there are variables for the following: version, secret, password, and metric. You can leave most of the default values as they are, unless you are more security conscious than the average internet user. If you live in one of the 3 countries that still use the imperial system for measurement, you may want to change the metric value. It determines the units of display for the collected data. The default units are metric. The other option is imperial. Let's suppose that you want to see your data in imperial units instead of metric. To set the values in the internal object, enter the command set internal. Gambezi asks for each value in the object in turn. You can enter a new value or keep the current value by just hitting the enter key. Enter false for the metric value. Now if you show the internal values again, you see the metric has changed to false. Once you have configured the values you want for paths and internal, enter save. This stores the values and returns to the Build Installer menu. Back at the Build Installer menu, we can now configure the data logger by entering Configure Logger. The logger is more complicated than the server. Enter the Show command. You'll notice that the logger has both a Paths object and an internal object. It also has a Sensors object. Enter Set Sensors. You'll find a new Sensors menu. Rather than being a simple object, Sensors is a list to which you must add sensor objects one by one. If you enter Show Types, you'll see there are currently two sensor types available, BME280 and Pi_internals. BME280 refers to the Adafruit BME280 sensor hardware that measures air temperature, humidity, and barometric pressure. Pi_internals measures the internal CPU and GPU temperatures on the Raspberry Pi. Enter the command add Pi_internals. You'll then be asked to enter three variable values. As before, the current default value is in parentheses. First, you enter a nickname for the object. This is useful if you are configuring multiple sensors. Since we are only configuring one, in this case, it doesn't really matter what you enter here. Second, enter the period. This is an integer value indicating the amount of time in minutes between data collection events. I'm going to keep the default. Third, enter a rollover count. Also an integer, this is the number of data readings that are written to each CSV file before a new file is started. Again, I'm going to keep the default value. After entering the desired values, enter Save to return to the Logger menu. Enter Save again to return to the Build Installer menu. Back at the Build Installer menu, run the Help command. We see the build command that will cause Gambezi to generate two install scripts, one for the server and one for the logger. Let's run it. After the build finishes, we can quit Gambezi by entering the quit command. Now if we look at the files in the Gambezi directory, we'll find two with a .sh extension. One starts with server install and the other starts with logger install. The version string you configured will also appear in the name. We need to copy these files to the Raspberry Pi to install the logger and server software there. To copy the files, make sure your Raspberry Pi is up and running. I've split the screen here so you can see my laptop on the left and the Raspberry Pi on the right. To copy the files from your computer to the Pi, you'll need to know the IP address of the Raspberry Pi you have. If you have just logged into the Raspberry Pi, you can find the IP address at the top of the screen. Otherwise, run the command IP address show, like I did before, to get the IP address. I want the IPv4 address associated with WLAN 0. On my Raspberry Pi, it is 192.168.200.74. Your situation may be different. You might have a different subnet, like 10.10.10. Or you might have just an IPv6 address. I'm not going to go into great depth here. If you see something different on your Pi, you may have to do some research. You will also need to have the SSH program installed on the computer where you ran Gambezi. If you are running Windows and don't have SSH installed, we have a wiki page describing how to install and run it. The link to the wiki page is in the description below. Note that the Secure Copy program, SCP, is installed when SSH is installed. In this tutorial, I'm using Windows Subsystem for Linux, also known as WSL, or as I like to call it, Weasel, to access SSH and the companion program SCP. To start it, I run WSL in an open command prompt. I can now copy the installation scripts to the Raspberry Pi by issuing the command scp *.sh and then the username for my Raspberry Pi. You should use the username you configured, the @ symbol, and then the IP address of my Raspberry Pi. You should use your own IP address that you found earlier. I then do a colon, a /, the word home, another /, and the username again. This will make sure that the installation scripts get copied to my home directory. You'll have to enter your password for the Raspberry Pi to make this work. Now if I go look on the Raspberry Pi, I can see that they were copied over. Once the scripts are copied over to your Raspberry Pi, they need to be run with root permission. Log into the Pi. You should be in your home directory, and the script should be there as well. Install the data logger first by running the command sudo /logger_install and the version number. You can just hit tab to complete the word. This will start the installation of the data logger. You may have to enter your password to continue. When the installation is finished, you can check to see if the data logger is running by executing the following command: systemctl status CCS data logger. It says that it's enabled and active and running. Press Ctrl+C to return to the prompt. Now install the data server by running the command sudo /server_install and press tab to complete the word. The server takes a lot longer to install because there's more to it. I'm going to speed up the video here so that you don't have to wait. When the installation is finished, you can check to see if the data server is running by executing the following command: sudo systemctl status CCS data server. Again, you should find text that says enabled, active, and running. And press Ctrl+C to get back to the prompt. Now open a web browser on another computer on your home network. It could be your phone, laptop, or desktop computer. I'm going to open the browser on my laptop. In the address bar, I type http:// the IP address of my Raspberry Pi, a colon, and 5000 for the port. When I enter that, I should see the latest collected values for the CPU, GPU temperatures, and the Pi throttled status. If you see the same, congratulations. Your data logger and data server software are correctly installed. Thanks for watching.